Hello, and welcome to another TA Tech Tip. In this tech tip, we will demonstrate how to set up a TGA mass spectrometry experiment on a Discovery TGA connected to a Pfeiffer Thermostar mass spectrometer. This video will cover how to set up a basic TGA-MS experiment in the Trios and Pfeiffer control software. We'll also provide tips on how you might plot the data from those experiments within TA Instruments' Trios software. For more in-depth information on the setup, operation, and maintenance of the Pfeiffer Thermostar mass spectrometer, you can refer to the Getting Started guide. You can easily access the Getting Started guide from the Trios online help using the Help button in the Trios software. From there, in the left panel, you can select Using the Discovery TGA and then Getting Started guides, where you will see the link for the Pfeiffer Thermostar mass spectrometer Getting Started guide. When running a TGA-MS experiment, you will decide whether you want to run a bar chart scan recipe or MID recipe for your mass spec data collection method. A bar chart recipe scans all the masses between a selected start and selected end mass. An MID recipe allows you to pick only the masses of interest, which can increase the frequency of scans during a run. Click on Create Edit Scan to create a new mass spec bar chart recipe or edit an old recipe. These recipes can be executed using an automatic sequence. Make sure that you select Bar in the top left corner. We can see which recipes exist, edit them, and save them, or create a new recipe and save that. For this example, we are running calcium oxalate monohydrate, so we do not expect a mass signal of interest above 44. We will scan from 1 to 45 here. We can also select the dwell time. Note how changing the dwell time and scan range changes the total duration of each scan. Click Save Parameters and you will be prompted to name the recipe you are saving. Once completed, you can hit Cancel/Exit. You can also edit or create a new MID recipe in the control software. Select New and pick the masses of interest. We are running calcium oxalate monohydrate under a helium purge, so we will just be looking at the mass signals for helium, oxygen, water, carbon monoxide, and carbon dioxide. Left-click on the grayed out row for channel state and select Enable. Put the mass of interest in the field for first mass. You then can select dwell times for each mass as you want. They do not all have to be the same. Again, note the effect on the total cycle time. Save and name the new MID recipe, after which you can exit. Once you have created or edited recipes which you want to use, you can create an automatic sequence. An automatic sequence will run the mass spec recipes in order. It can be triggered to run from the Trios software so that each mass spec data file is analyzing the off gases of each TGA experiment in order. You can run the same recipe for every test in the sequence or use different ones. Select the recipe you will use and double-click to put it in the sequence. You can then edit the name of your data file. It is a good idea to follow the naming convention you will use on your TGA experiments. Here, we will be running two different TGA-MS experiments on calcium oxalate monohydrate. One, we will analyze the off-gas with a bar chart recipe. The other, we will use an MID recipe. Once we are ready, we can select Use Sequence. You will see the list of recipes in the queue and the message indicating that the software is waiting for a trigger. The trigger will come from the Trios software during the TGA experimental procedure. When our sample is loaded and ready to go, we can create a new run. The order of the runs in the TGA queue needs to match the order of the queue set up in the mass spec control software. We will create our new experiments and name them so that they will be matched to their corresponding mass spec files. We will build this as a custom method. It can be good practice to include a preliminary purge at the start of your method prior to a ramp. If you only want your data to include the ramp, you can turn off data collection for the isothermal purge step by using a data off and data on step on either side of the isotherm. When TRIOS data collection begins, you will put an Event 1 on step. This is the trigger for the mass spec to begin the next queued recipe. You want the Event on step to correspond to the beginning of data collection in TRIOS, so that the time points for each data file are aligned. At the end of your TRIOS method, include an Event off step. This ends the mass spec data collection. The next mass spec recipe in the queue will move to the top of the list and wait for the next trigger from an Event on step. We can append this method for the second run in our sequence. As long as the TGA experiment we want to do is the same, which it is in this case, we are ready to begin. After the TGA runs are completed, we can navigate to the Results tab. We can open up the corresponding mass spec result files directly in TRIOS. Open files from the TRIOS Results File Manager. The mass spec result files have the extension .xlh. The default location for the mass spec results files can be found by going to the C drive and following the path of the Sandbox folder, H6P3L1 folder, and finally, the Data folder. You may want to make a shortcut to this folder in order to get to it quicker. After opening the result files of interest, you can analyze them in TRIOS. The mass spec files have ion current signals for the measured mass fractions over the time of the experiment. If you would like to plot the mass spec data and directly compare it to the TGA weight loss data with respect to temperature, then you need to give the mass spec file the appropriate temperature information. Hold down the Control key and select the TGA and mass spec file which were run together. Then right-click. You will see at the bottom of the right-click menu the option for transformations. There you will see Add TGA Temperature Data. This creates a new mass spec data file with all of the data it already possessed, as well as a temperature variable which was given to it by the TGA file. This is why the beginning of data collection needs to be aligned for the TGA and mass spec data files. The new file has the name of the original mass spec file with an additional -TEMP at the end. Make a new overlay file and drag and drop the steps of interest. For this TGA data, we are only looking at a single ramp step. The mass spec files in TRIOS separate the masses into their own steps, so they can be added individually. We can see for the bar recipe, we have masses from 1 to 45. For the MID recipe, we only have steps for the masses we had previously selected. You can drag and drop individual masses onto the overlay, like 18 for water, which we expect on the first weight loss. Then you can select ion current plotted on a log scale to easily view it. Here we can see how the mass spec signal agrees with the weight loss derivative. You can also select multiple masses at a time and pull them over at once, like these 28 and 44 for carbon monoxide and carbon dioxide, respectively. Interestingly, in this case, we can see that carbon dioxide was produced along with carbon monoxide in the second step. By plotting oxygen, we can see that carbon monoxide reacted with trace oxygen to create carbon dioxide. In this TA Tech tip, we went over how to set up a TGA mass spec experiment with the Discovery TGA and Pfeiffer Thermostar mass spectrometer. Please stay tuned for more helpful tips from TA Instruments, and thank you for your interest.